So, hello students, how are you? I hope you are doing good. Good afternoon to everyone. So, firstly, make sure the screen is visible to you and I'm audible to you, and then we will start the lecture. Okay. So, we will wait for 1 or 2 minutes more. Let the others to be joined, है ना? And then we will start the lecture. How's your preparation is going on? Is it fine? Preparation तो अच्छी ही चलनी चाहिए ना? We are doing great. अच्छा. It's good for you. You're doing great. Yeah. Definitely, the practice makes you perfect, na? And good practice. So try to solve as many numericals as you can. PYQs, conceptual questions. Read the theory. Read your notes. Okay. Do not focus on the facts. More. Do not focus more on the facts. I'm not saying that just left the facts. Yeah, keep remember the fact, but focus more on the concept. That will be more beneficial for you. Okay. So it's a game of practice. Okay. Practice with sincerity, practice with discipline, practice with consistency. And consistency is the key to success. Okay. Swami Vivekananda has once said that without consistency and discipline, you can't achieve anything. Okay. So if you want to achieve anything, if you want to defeat your goal, defeat your aim, okay, all the obstacles coming in between, then you have to be disciplined and consistent. Okay. So focus more on the practice. Dedicate at least your 5 to 6 hours or 6 to 8 hours, I must say, from now. Okay. So here we are with our lecture number 10. Okay. Of semiconductor, and this should be this is the last lecture of this series of semiconductor. Oh. We have covered that what kind of solid material we have. Based on that, we classify the solid based on their electric conductivity, which is like conductors or metal, you can say, insulator and semiconductor. Then we have learned about the energy band gap theory, and we have classified that how the conductor will become a conductor, and how the a semiconductor will behave as a semiconductor, and how insulator is not capable of flowing the current through it. Okay. We have also learned about the valence shell and conduction shell. What is the energy band gap? You know? So all of this we have learned. After that, we have classified the semiconductor itself. on two category, which is intrinsic semiconductor, extrinsic semiconductor. Intrinsic semiconductor are the natural conductors we have. This is the pure element or compound. Pure element means silicon and germanium mostly you have. And in compound you have anthracene, cadmium sulfide, and etc. Okay. Gallium arsenide. Then after that we have learned that what is an extrinsic semiconductor, why do we need that. So extrinsic semiconductor are those who are doped with some kind of impurities or foreign impurity you can say. Okay. Because the conductivity of intrinsic semiconductor is too low, so that is why we need to dope some foreign impurities into the intrinsic semiconductor to make it more conductive, and that semiconductor device is termed as extrinsic semiconductor. We have two type of extrinsic semiconductor, p type and n type, है ना? In p type majority charge carriers are holes, which is the positive charge carrier, and in n type majority charge carrier are electrons, free electrons. Okay. The doping impurity, we have two types, trivalent impurity and pentavalent impurity, है ना? In p type semiconductor we doped trivalent impurity, which is aluminum mostly, and in n type semiconductor we doped it with a uh, pentavalent impurity, which is phosphorus or arsenic. Okay. Then after we have seen the relation between hole current and the conventional current. The intrinsic charge carrier concentration we have also learned. Okay. After that, we have joined these two semiconductors to form a new device which is termed as diode. And this device is termed as p-n junction diode. We have seen that how a depletion layer will form when we join a p and n junction, p and n type of semiconductor. What is the concept of depletion layer? How does it form? All we have discussed. Okay. It is formed because of the energy filled by the free electrons in the junction region. Okay. And it becomes in that region the immobile charges are present. So that is why they form a depletion here. Then we have joined a circuit with the help of this diode, and we have flow the current through that in two condition, which is reverse biasing and forward biasing. In forward biasing, the diode will behave as a normal conductor and it allows the current. In reverse biasing, it does not allow the current, it does offer a very huge resistance. Okay. But when you continuously increasing the voltage, then a certain voltage it reaches called breakdown voltage or avalanche voltage. At that particular voltage, a very large value of current, very large amount of current will flow in reverse biasing condition that will burn out the diode. Okay. Or in forward biasing also there is a voltage called knee voltage. After that you will able to use that diode as a conductor, okay, as a flow device. Okay, it allows the current and as a very extreme extent. Okay. After that we have seen that special p-n junction diode, which is basically Zener diode, light emitting diode, photodiode, and solar cell. Okay. In Zener diode, it works only in reverse biasing, and it act as a what is the use of Zener diode? Zener diode we use as a voltage regulator. Okay, because around it, if you join a Zener diode in a circuit in reverse biasing condition, so the large value of current flown in the reverse biasing situation, it absorb that values of current and maintain the voltage constancy, okay, in the circuit. That is why it is used as a voltage regulator. The Zener diode I'm talking about. Now, all of the students that are joining now, I am telling you that we are doing a revision of what we have learned till in 10 lectures of semiconductor. Okay, got it. So we have learned the special p-n junction diode, which is Zener diode. Zener diode act in always work in reverse biasing situation, and it also act as a voltage regulator. That is the use of it. Then after we have learned about a rectifier. Okay, we have two types of rectifier: full wave and half wave. What is a rectifier? It is a combination of p-n junction diode. What does it do? It just convert the direct current, alternating current into direct current. Okay. If it is converting the half wave, then it is termed as half wave rectifier. And if it is converting full wave, then it is termed as full wave rectifier. Okay. After that, what we have learned? We have learned about the filter in rectifier circuit. So if you connect it with a capacitor around it in parallel situation, then the filter you will have and a constant current, which is the direct current you will have with a purify value. And after that, we have learned about the photodiode, on which how the photodiode will work. Photodiode absorbs the light, then it circulates the current. Okay. What is light emitting diode? It takes the value of current, then emit the light. Okay. It just opposite to the photodiode. Okay. LED you most commonly see in your household, also in your school, in your classroom. There must be LED bulb. So that is the light emitting diode that is used in that. Okay. Or in that case, the photodiode will work opposite to each. Okay. You put the light on photodiode, and then it will activate the circuit. Okay. Now, after that, we have learned about the solar cell. Solar cell is what? Solar cell is a device which convert the light energy into electrical energy, in which also we have this layer of p and n junction diode. But the n junction diode, the n type diode layer is very thin, which is exposed to the sunlight. And why it is so? So that sunlight, the photon that are coming from the sunlight can easily absorb by it. Okay, na? And they can easily go through the depletion layer to activate the charges. Got it? So this is all we have learned so far. And in the previous lecture, just before today, we have learned about the logic gates and signal. So what we are going to do today, we are just going to finish this chapter, okay, with some numerical problems, and two more gate you have to learn. A second. Two more gate you have to learn, which is not that important, but the chances of asking in examination is little bit high. Okay. So you cannot say that these are not completely no use, can be useful. Okay. So firstly, we will revise some concept in the previous lecture what we have done. So in the previous lecture we have done signal. What is signal? I have told you it is an electromagnetic current or wave. Okay, which carry a information and it transfer the information from one place to another place or one device to another device with the help of networking. Okay. So these are the signals. So we have two types of signal: analog signal and digital signal. Signal, again I'm telling you, signal is a electrical or electromagnetic current or wave which is used to carry the data or information from one device to another device with the help of a networking system. Okay. There are two types of signal that we have, is the analog signal and digital signal. Analog signal, I have told you that it is a continuous form of signal. Okay. So it is more prone to distortion. Hmm? And it is represented by a sinusoidal wave. Sinusoidal wave. Okay. So this is the representation of this analog signal. जैसे हमारी voice. Digital signal is a discrete or discontinuous form of signal. ठीक है? Although it is a square wave, but it is discrete, which means at a particular time stamp you have the value, and another time period you do not have any value. Okay, so this kind of situation is termed as the binary form. Binary form means only two digit you have, only two responses you have, either it is on or it is off. Okay, so these are the digital signal 0 1 0 1 0 1. Okay, 0 means low voltage और वन मीन्स हाई वोल्टेज. ठीक है, और यू कैन से जीरो मीन ऑफ एंड वन मीन ऑन. ठीक है, so these are the representation. It is represented by square waveform. Okay, like this you can see on means 1 and off means 0. This these are the digital signal. In logic gate, we have covered the logic gate is nothing but a circuit, digital circuit with a logical relationship. Okay, between input and output. Okay, so there are input followed by a logical relationship and then output. Got it? Now, the basic building block of any digital electronics devices which process this digital signal in a specific manner is the logic gate. Got it? So we are using this logic gate in calculators, digital watch, computers, robots, industrial control system, and telecommunication. Okay. So we have five common logic gates are these: not, and, or, NAND, and NOR, in which not, and or, in which these three are the basic or fundamental. These are the basic. And these two and another two that I am going to discuss today are derived from these three. Okay. Now, truth table, I have told you, truth table is the all the possible combination that can be have with the logic gate. It is represented by a truth table. Okay. Logic gates work in the binary form, which means zero or when you have zero and one are the only input you can do. Okay. And then as logical relationship, and on based on that logical relationship, you deduce the output of it. Okay. So firstly, basic gates are those: NOT gate, OR gate, AND gate, and the universal gates. The possible combination with these three are the universal gate, which is NOR and NAND. So NOT gate में क्या होगा? One input, one output, which means it rejects all the input you will give. If you are giving it zero, it rejects it and then it produces one. If you are giving it one, then it produces zero. So it is a simple inverter, you can say, because it inverting your input. So this is the truth table of it. Input is 0, then output is 1. Input is 1, then output is 0. And this is the logical symbol. Remember this dot. Okay? So you can say it a inverter. Okay? Inverter. It is also known as inverter. Now, OR gate, two or more input. दो से ज्यादा input होंगे, one output. ठीक है? This is the logical symbol of it. The curved line. These two. It is like a arrow. ठीक है ना? Front end of arrow. So the truth table of it is 0 0 means 0. So if any of the input is 1, it will give you as output as 1. Okay. So 0 0, there is no 1, so it will give you 0 in this situation. But if the input is 0 and 1, it will give you 1. Input is 1 and 0, it will give you 1. And 1 1, it will give you 1. Okay. Now you can say 1 is high and 0 is low. AND gate is also represented by this. This is the logical symbol of it. This line, the input line is straight. So input are 0 0, then it will give you 0. If both the input are 1, yeah, both the input are high, then only you will receive a high. Either in other case it will 0. So 0 0 is 0, 0 1, because not the two inputs are high, so it will give you 0. In this situation also only one on input is high, so it will give you 0. In this situation 1 1, both the input are high, so it will give you output as high. Okay. NAND gate is nothing but what? AND plus NOT. AND gate followed by NOT gate. So whatever relationship you are getting with NOT gate, AND gate, whatever output you are getting in AND gate, you just reverse it, and then you will have a NAND gate. So this is the symbol. Put the dot in front of the AND gate, you will have a NAND gate as a logic system. Okay. So 0 0 in AND gate, what will be the output? 0 0 means 0, but it is NAND. You have to follow AND plus NOT. So in AND gate, 0 0 will give you 0, but it is followed by a NOT gate also. So it just invert that output, which means 0 inverted into 1. Again, 0 1 will give you 0 in AND gate, but followed by NOT gate, it will give you 1. So only this case, in 1 1, it will give you 0. Okay. Similarly, the NOR gate is OR gate followed by the NOT gate. Okay. So whatever output you are having in OR gate, you just invert it and you will have the NOR output. 0 0 in OR gate, 0 0 gives you 0, but it is a NOR gate. You have to invert that output, so it is 1. Okay. And all the other output will be 0. Now this I have to discuss with you. This is the exclusive OR gate, XOR gate. Although it is not given in the textbook also, most of the textbook just not included it. Okay. But for the information of you and for the conceptual understanding, if you see this in your examination hall, then you will blame me, na? Oh, sir has not told. So I am to told you. So this XOR gate is nothing but exclusively OR gate. Yeah. XOR means exclusive, exclusive OR. Okay. It is a OR gate, but it will exclusively select one. Okay. Which means in OR gate, if you see this is the logical symbol, you put a curved line in front of the OR gate. So if input is 0, 0 0, so in OR gate you will have 0. In OR gate, this is 0 and 1 will give you 1. 1 and 0 is also give you 1. But when both the input are high, so it will give you 0. So it exclusively select one value as the output. Okay? Only in these two situations it will give you high, or in other situation it will give you the low output. So only one change is there. When these two values are high, both the input are high, it will give you a low input. Okay? This is the exclusive one. So two or more input, but only one exclusive result it will give you. Okay? It will exclusively select one only. Okay? So if there are one in the output, it will give you high, but if both the input are same, then it will give you 0. Okay? Similarly, this is exclusively NOR gate, which means it is a NOR gate, but exclusively NOR. So how does it different from that? In NOR gate, you will have 0 0 as 1. So in exclusively OR, you will have also 1. In NOR gate also, if I talk about NOR gate, 0 1 gives you 1 for OR, but it is a NOT gate, so it will give you 0. And 1 0 is also 0 in NOR. But if this is a exclusively OR gate, NOR gate, then it will specifically select this. So there is exclusively one high in the input, it will give you a low because it is NOR gate, not OR gate. Okay. In the previous, if you will see, it will only allows the current when only one exclusive input is high. Okay. So similarly, this is because of this N, it will reverse this situation. So in that case, you will have 0, 0 as 0. So it is NOR. So you have 0, 0 as 1. In that case, you will have, in this scenario, you will have 0, 1 as 1. So in this case, you will have it 0. Okay. So I hope you are clear with this. If you have any kind of doubt, you can ask in the chat box. Now, the Boolean algebra we are talking about. Now, what is a Boolean algebra? So there is a scientist or physicist, you will say, the George Boole. So George Boole has studied these logical symbols and logical outputs, and based on that, if it he form a algebra to that. Okay, based on the binary input and output. Okay, and that algebra is termed as the Boolean algebra. It is different from the algebra that you have learned in your mathematics. So it is different from that. Okay. So in Boolean algebra, there are several terms. If I talk about this A bar, this is the input. Okay, and this is output. Let's say, just a second, input and output. So if input is A and you apply a Boolean algebra term which is bar, which means A bar, so it will just reverse the input. This A bar is termed as the NOT. So the NOT gate we are using now, it is represented by A bar. Okay. So in NOT gate truth table, what is happening? If input is 0, then output is 1. If input is 1, then output is 0. So you can represent the NOT gate by A bar. This is the Boolean algebra symbol of that. Okay. Now, the OR situation. In OR gate, what we have? We have two input. So OR gate is represented by plus. So we can say this bar is represented, this is A bar is represent the NOT gate. This plus represents here the OR, and the dot represent the AND situation. Okay. So if you want to write A or B, it will give you A plus B. Okay. Or you will cite there are two input A and B, and the operation is plus, so it will give you A plus B. Okay. A dot B. There are again two input A, B, and the operation is dot, so it will give you A dot B. Now, if I talk about the output, if A, this is A, this is B, and this is output Y. So if input is 0, 0, 0, 1, 1, 0, and 1, 1. So according to these symbols, what are the possible output? Okay. So I will write it as here A plus B, A dot B, and A bar. Okay. Got it? Because in NOT gate only one input and one output is there. So you can say that A plus B, 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. Now 1 plus 1 is 2? No. and that is why it is different from the normal algebra. 1 plus 1 is also, okay. Now, if you, this is the correct representation of OR gate. If both the input are low, then it will give you a low output. If one of the input is high, it will give you a high. Okay. So it is satisfying our situation. Now A dot B, 0 dot 0 will give you 0. 0 dot 1 give you 0. 1 dot 0 is also give you 0. 1 dot 1 is give you 1. So that is also satisfying our situation. In AND gate, because dot is represented the AND. In AND gate, if both the input are high, only in that situation you will have a high output. All the on all the other possibility you will have zero output. है ना? In NOT gate, I have tell you that it just reverse the situation. 0 converted into 1, 0 again converted into 1, 1, 0, 0. I hope you are clear with this Boolean algebra term. Now, there is a theorem of Boolean algebra which is termed as the Boolean theorem. So what is it said? It said that A dot B bar is equals to A bar plus B bar. So this you have to keep in your mind. Now, this is the theorem. A dot B bar is equals to A bar plus B bar. Now, what is it saying? It is saying that A dot B ka bar. A dot B is the AND gate, and bar of it will give not. So AND plus not gives you NAND. भूले तो नहीं ना? It will give you NAND. So let's just check it. So the combination of A bar plus B bar, which means 2, it is the 2 NOT gate, gives the same output as NAND gate. And let's just see it. Okay. Because this bar represent the NOT gate, this dot represent the AND situation. So you will see that this A dot B means, firstly this A dot B means and we put a bar on it, then it will followed by a NOT. So AND plus NOT gate I have also clear it with you. What is that? AND plus NOT will become NAND. Okay. Now, if this is the correct situation, then we will have the same output. And this is the AND gate. This is for A. And again, we have another input. So in this situation, if you will see, this is B. So if A is 0, okay, B is 0 input, then output will be 1 and 1. Okay. And I have connected it with the same line. So it will give you, let's say this output is A dash and this output is B dash. And because I have connected it with the same line, so A dash is equals to B dash. Now A dash is 0 to 1, so B dash will also be 1. Which means on putting 0, it will give you 1. Okay? 0, 0, 1. Now, if you see, if you make it 1 and it make it 0, then 1 will give you 0, 0 will give you 1. है ना? And this is a NOT situation. And if you will compare it with NAND gate, so what is NAND gate? Symbol of NAND gate, it is AND plus NOT. है ना? Now, this is A, this is B. If you give it here 0, here also 0, then output you will have as 0, 0. AND gate means 0, but NOT is 1. And that is what we are having at 0, 0. At 0, 0, that is what we are having. है ना? Got it? So this is how, this means we can convert this to, we can use this two NOT gate to make a NAND gate. In this, I have forgot to mention one thing. To one at least connect the AND gate also. ठीक है? So these are the input of AND gate. So if input is 0, then it will give you 1 here, 1 here. Then AND gate will give you 1. If input is 0, it will give you 1. If this input is 1, it will give you 0. 1 0 will 0. ठीक है? Got it? Now, so this is the Boolean algebra. ठीक है? You can write the combination of gate with the help of this Boolean algebra. ठीक है? So I hope you are clear with this term. Now we are going to learn the integrated circuit, IC. You have must heard about this term whenever your television or mobile got any kind of trouble. Then usually the people say that iski IC fuk gayi hogi. IC is not working. But what is that IC? IC is the integrated circuit. So what we have do, we have take the entire phenomena of this logic gates and put it on a single block. Okay, so let me show you the concept of fabricating in the entire circuit on a small single block is termed as the integrated circuit. ठीक है, जिसे हम चिप भी बोलते हैं. ठीक है. So what we have do, we have fabricate the entire circuit, the capacitor, the resistance, the inductors, the diodes, and we just fabricate it with on a single block. Okay, that is termed as the integrated circuit. These devices, these are the integrated circuits or ICs. Okay, now. So the entire circuit include the passive component like R and C and active devices like diode and transistor. I will ask you one question. How many of you know about that what is the passive component and what is the active component? Okay, just answer it. So I will explain it to you. Okay. Every one of you know about the active and passive component and why it is said that so. Why the active component is called active component and why passive component is called passive component? So every one of you has answered. Okay. So that I will explain it to you now for the better clarification of yours. So Veera, Pooja, C, students from JNV Ongole. Please respond, na? My God. JNV PTA guys, please respond if you know it or not. This is the trouble, na? You guys don't respond it. So how do I know कि you know it or not? ठीक है. Okay, okay, Navya, I got it. It's for the your goodness na yaar. It's for your better understanding, that if you will respond, so that I would know ki you know this or not, then I will re-explain it. So it is for your betterment. So please involve in this activity. Okay? Please be responsive. Got it? So if I talk about the active devices or passive devices first. So passive device, your passive component. Passive components, generally we will have resistance, inductor and capacitor. So why it is termed as the passive component? Because they absorb energy and they do not require any kind of energy to operate. Okay? They are inbuilt. So do not require any kind of energy to operate. Okay? That is why they are termed as the passive component. Okay? Now active component. Active components are diode, transistor, amplifier. Why it is termed as the active diode? Because they do not absorb the energy, but they require the energy to be operated. Okay? They require energy to operate. And also in the passive component, they cannot control the flow. Okay? But the diode, transistor and amplifier can make the decision of the flow of electricity. Okay, na? Logic gate is the best example of it. Now, so in this entire circuit, what does we have in this entire circuit? We have the passive component like R and C, and L is not included in that. Okay? Active devices are like diode and transistor. Okay? So the combination of that will become a IC, integrated circuit. So the widely used technology that we have in this field is monolithic integrated circuit, which is termed as MIC. Okay? It is just for your knowledge. Not that much kind of important is this. So types of ICs on the basis of nature of input signal. So we have two types of IC there. The linear or analog IC. It is process the analog signal. And I tell you in the very first of this lecture that analog signal are continuous in nature. So this IC, the linear IC or the output of this linear IC or this analog IC will also be a continuous in nature. Okay? And digital IC, the same. It processes the digital signal, which means it is a discrete output. It has a discrete output. Got it? Now, so it processes the analog signal with the change smoothly and continuously. Why it is so? Because analog signal itself is changing smoothly, continuous manner from maximum to minimum. For example, the sine wave we have taken. है ना? So output varies the linearly with the input. Now in digital IC, process the digital signal. Digital signal we have in binary form. Binary form. Okay. 0 and 1. So which have only two values, which is 0 and 1. So output varies linearly with the input in this situation also. And this contains a circuit as logic gates. तो इसमें होते हैं logic gates. किसमें? Digital IC. So based on the number of logic gates, we have derived, we have classified this digital ICs based on the number of logic gates it have. So if I have a small scale integration SSI, which means logic gate is less than or equals to 10. If we increase the number of logic gate from 10 to 100 and keep it in between 10 to 100, then that system is termed as the MSI. There is a company which of laptop manufacturer company named MSI, है ना? So is the medium scale integration. Okay, it is not that company name is this. No, it is the IC name based on the number of logic gates. So MSI means medium scale integration. Large scale integration, which is LSI, 100 to 1000 के बीच में होगा. And then in the very last we have very large scale integration, which is VLSI. ठीक है, which have at least greater than 1000 logic gates in the circuit. It is the industrial application of that. Industrial level पे हम इसे use करते हैं VLSI. ठीक है. सो फर्स्ट किसने इन्वेंट की थी? जैक किल्की ने इसे इन्वेंट किया था टेक्सास इंस्ट्रूमेंट में 1958 में. ठीक है. नोबेल प्राइज भी मिला था भैया इसे फॉर दिस इन 2000. ठीक है. सो IC are produced on a piece of semiconductor crystal or chip by a process called photolithography. ठीक है. सो इस प्रोसेस को याद रखना. What is this process called? Photolithography to produce IC on a semiconductor crystal. Okay. Now, what is Moore's law? Moore's law said that number of transistor on a microchip doubles about every 2 years, and though the cost of computer is half. Okay. पहले जो कंप्यूटर की कॉस्ट होती थी वो बहुत ज्यादा होती थी. I will tell you about myself. Then I have bought a laptop in 2014, and it is very heavy and very slow, but at that time it feels that it is very good. Now if I compare that laptop to my this laptop, or the same number, I have purchased it on 25,000 rupees. Okay, at that time 2014. Now if you are going to purchase any laptop and 25 to 30,000 rupees, you will get a good laptop with i3 processor, the i3 Intel or Ryzen 3 you will have, and you will have at least 8 GB dedicated RAM. Okay. But in that laptop in 25,000 I have only got 1 GB RAM. That is all I have got. Okay. And it is not 5G inbuilt, it is not 4G inbuilt. It was not. Okay. And it was very heavy. So since the number of transistor of microchip, the microchip is the processor, okay, doubles every 2 years, then the cost will half. Okay. So the laptop you are getting for today about 50,000 rupees, in after 2 years you will have the half of it, the price. It will cost you around 30,000 or 35. Okay. Got it? The speed or capability of computer will also increase and the price will decrease. So it is very logical, because if the processor uh, include very large number of transistors, then it will also half the cost, because it will save the space, save the manufacturing process, save the cost. So it will also decrease the cost of laptop. Okay, or this computer you are in. Got it? Now this question you can solve. So we have to write the truth table for this circuit given below, consisting of NOR gate. So firstly, tell me what is this gate for? This gate is NOR. And this gate, I am talking about only this gate. This gate is also NOR gate. There are two NOR gate in this. So we have to calculate the truth table. We have to draw the truth table for it. A and B is the input and Y is the output. You have seen here that only single output is produced, then it is connected by two lines, which means whatever the output is, let's say here A dash and B dash, and you have produced input Y dash. So you can say that Y dash is equals to A dash is equals to B dash. Okay? So if you try to write the truth table for it, now if you talk about the first gate, 0 0, it is a NOR gate, not plus or plus not. So 0 0 will give you 1 because it is or plus not. 0 1 is 0, 1 0 is 0, 1 1 is 0. So Y dash, you have 1 0 0 and 0. Okay. So both the input for the second gate is Y dash. Now I have tell you that this Y dash distributed same at this junction, because to operate a NOR gate you have two input. You require two input. So this Y dash and this is also Y dash. Okay. So if Y dash is 0, this Y dash is also 0. Then 0 0 will give you 1 and 1 1 give you 0. Okay. So finally this is the table for first gate. This is the table for second gate. Now the over gate you will have 0 0 as 0. Okay. 0 1 1 1 0 1 and 1 1 as 1, because Y dash is the output of first gate. Do not confuse with it. After that the second gate apply and this is the final output Y. Okay. So 0 0 is 1. Okay. And 1 1 is 0 again. Okay. Got it? Okay. So I hope you are clear with this question and all the concept that I have told you. So this chapter is finished for today. So I hope you have understood it. So if you have any kind of doubt, you can ask in the chat box. Otherwise, the lecture is being over. Thank you so much for being attentive and take care of yourself. Keep studying. Okay? That is the key to success.